This is the equation for a simple harmonic oscillator. We all know solutions are sinusoidal waves of this sort of form. It has an amplitude A, and then it's phase shifted, so you can slide this picture left or right, and it'll still be a solution of this equation. Omega naught, the natural frequency this thing oscillates at, the square of it is k over m, which means that omega naught is equal to the square root of k over m. If we plugged this form into this equation, we would in fact see that the equation is satisfied by this, since the second derivative of cosine is again a cosine, which will then be equal to a cosine term on the other side. It's usually useful to rearrange this so that both terms are on the other side. This is a nice looking form because eventually we're going to change this zero into an external forcing term, which is really where this harmonic oscillator gets a lot of its power. We can, in a closed form, show what the response will be to any force we apply to it. Another form that's very often useful to represent the solution is the phasor form, where we assume it's a complex phase and an oscillating exponential on the side. It's understood that the real part of this is the actual solution we're talking about. We don't actually have oscillators that have a complex position. That's sort of silly. It's always going to be real, but it's a mathematically useful trick to put it in this form. When we put that into this equation, we do in fact see we get minus I omega squared plus omega naught squared equals 0, which implies that omega is equal to omega naught, as makes a lot of sense. Now what we can use is a fancier technique, Fourier transform, to analyze this equation. There's two ways of going about it. We could slap the Fourier transform on the side right here, or we could use the synthesis equation and substitute any instance of x of t with this integral equation for the x of t in terms of this Fourier transform spectrum. And in fact, if we do that, we find that the derivative can be pulled inside of here, and then we can act on this exponential, which will bring down 2 powers of I omega, which will then be in this form. And then to make this equal to 0, once again, omega has to equal omega naught.